Hello student. In the last period we have already learned about the application of logic in a switching circuit. In this case we have already studied the circuit diagram or connection of a switches. There are two ways we can join or we can connect a switch. That means first one is in series connection and second one is in a parallel connection. So in a series connection, we compare a series connection in logic as a conjunction, and we have the table of conjunction as a P conjunction Q is T if both are T, otherwise it is false. And again we compare disjunction as a parallel operation, parallel connection. That means in a disjunction there are only one possibility, that current does not flow when both switches are open. So it is a basic idea about connection. That means connection are done by only two ways. That means in a series and other is a parallel connection. So next we have to learn the construction of circuit diagram, and after this we have to learn the construction of switching table. So first of all we construct a circuit diagram of any logical statement. There are two methods. In the exam we always give a logical statement and we have to obtain a circuit diagram from given logical statement. And another one is we have given a circuit diagram and we want to find out the logical statement. It is a different method. So first of all we construct any circuit diagram of any logical statement. So consider, for this purpose we have to consider one logical statement. After this we have to draw the circuit diagram of that logical statement. So first of all consider any statement, that is P disjunction negation Q, P disjunction negation Q, disjunction with P conjunction Q, P conjunction Q. So observe this statement, read as P disjunction negation Q, disjunction with P conjunction with Q. While we draw the circuit diagram of any logical statement, we have to consider P as switch S1 and Q as switch S2. So for this purpose we consider P as switch S1, Q as switch S2, and negation of Q. Here we are given negation of Q, and negation of Q is nothing but it is a S2 dash. That means S2 is a Q and S2 dash means it is a negation of Q. So first of all when we construct a circuit diagram we have to consider P as S1, Q as S2, negation of Q as a S2 dash, or if we given three statement then we consider third statement as R, P, Q, R. So in this case we have given two statement, P, Q and negation Q. So we have to construct here the circuit diagram of given logical statement. So first one, consider this bracket. What is the meaning of this bracket? That means P and negation Q. P is S1 and negation Q is S2 dash. So it is S1 and S2 dash. So what is the meaning of disjunction in case of switching circuit? That means S1 and S2 are connected in a parallel ways. So first of all we construct S1 and S2 as in a parallel way. So consider, or we have given S1 and S2 are connected. S1 and S2 are connected in a parallel ways. Again secondly consider P conjunction with Q. again consider P conjunction with Q. That means this bracket is connected with this statement in a parallel way. So P conjunction Q, that means it is connected in a parallel way. That means we have to construct a parallel line to this statement. So what is next statement? That is P conjunction Q. That means P is S1 and Q is a S2. That means it is S1 and it is S2. So this is the circuit diagram, and we have to connect to the positive terminal and negative terminal of battery. So it is the symbol of battery, that is two parallel line, where small line indicate negative terminal, and large, that means large line indicates the positive terminal of battery. So it is a light. So observe this, P disjunction negation Q is nothing but it is S1 and S2 are connected in a parallel ways. So S1 and S2 dash, S1 and S2 dash are connected in a parallel ways. Again it is connected with parallelly with P as S1 and Q as a S2. That is S1 is connected with S2 in a parallel series way. So both the switches are connected to terminal of battery, that is positive and negative terminal of battery, and it is the symbol of light. Or we have to check whether the current is glow or not glow. That means light is glow or it is not glow. So it is a theory how to construct the circuit diagram of given logical statement. So it is a first case. In this again we consider any statement and we can obtain the circuit diagram of any logical statement. So again next thing we have to study, that is if we give a logical statement. That means if we have a logical statement and we have to construct a switching table of logical statement. In this case, whenever we construct a switching table of any logical statement, we have to apply the flow value, that is 0, 1, 0, 1. That means 0 for T and 0 for F and 1 for T. That means we have to apply 0, 1 or 1, 0 as a flow value replacing T and F. So same procedure like construction of truth table. If we have constructing the switching table, in this case we have to only replace T as 1 and F as a 0. So consider any of example to construct a switching table. So construct any switching table by using any suitable logical statement. So consider P disjunction Q conjunction with negation of P disjunction with Q. So we have to obtain the switching circuit. We have to obtain a switching table of this logical statement. That means P disjunction Q conjunction with negation P disjunction with Q. So here first of all, whenever we construct a switching table, we have to consider P as S1. That means P as a switch S1, Q as switch S2. In this case, we have to obtain negation of P. That means we have to obtain S1 dash. Negation of that means S1 dash. We have considered P as S1 and negation of P as a S1 dash. So for this purpose we have to construct a switching table. It is similar to like the construction of truth table. In this case we only replace TF as 0 and 1. So we have to construct a switching table. For this purpose, we have to obtain how many rows and how many columns are present in that truth table. We can obtain advancedly. That means we have two statements. That means there are 4 rows. That means 2 raised to 2. That is equals to 4 rows. So how many columns are present in that table? That means columns are depend on number of basic connective plus number of statement. So here we have given the two statements P and Q, and we have to P, Q and negation of P. There are 3 statements. So we have the number of column, that is equals to number of statement plus number of basic connective. So we have two statements P, Q, that means 2 plus basic connective is 1, 2, 3, 4. So we have 4 plus 2, that is equals to 6. 6 is the number of column present in this truth table. So construct a truth table as like this manner, that is P, Q. Consider any bracket. That means we have to obtain P disjunction Q. If we consider first statement, and second one is negation of P disjunction with Q. We have to obtain, first of all we obtain negation of P, again negation of P disjunction with Q, negation of P disjunction with Q. And lastly we have to obtain P disjunction Q conjunction with negation P disjunction with Q. So give the number of respective table, respective column, that 1, 2, 3, 4, 5, 6. There are 4 rows. There are 4 rows. That means we have 2 statement. That is this table having a 4 rows. And how many columns? That means 6 columns. That means 2 plus number of basic connective 1, 2, 3, 4. So 4 plus 2 equals to 6. So 6 is the number of column present in this table. So while we constructing a switching table, we have to replace TF as a 0, 1. So 0, 1 is nothing but it is a floor value. So we have the outcome of P, that is TT FF, that means 1, 1, 0, 0. Again Q is nothing but it is TF, that means 1, 0, 1, 0. Again third column is P disjunction Q. P disjunction Q, that means P as S1 and Q as S2 is connected in a parallel way, and we have the column of parallel way. That means P disjunction Q or S1 connected with S2 in a parallel way. So we have the column of parallel way, that is both the switches are open, then current does not flow. That means 0, 0 has value 0, otherwise it is 1, 1. That means if in a disjunction P disjunction Q is F, if both the value are F. So negation of P is nothing but it is the opposite to P. So P is 1, 1, 0, 0. Therefore negation of P is 0, 0, 1, 1. Again we have to construct negation of P disjunction with Q. So negation of P present in column number 4 and Q is present in a column number 2. So we have to take operation on column number 4 and Q as a disjunction. So negation of P disjunction with Q. So column number 2 and column number 4 we have to take a disjunction operation as we have 1, 0 in disjunction. 1, 0 is 1, 0, 0, 0, 1, 1, 1, 0, 1, 1. Again in a last column. That means it is a given statement. That means P disjunction Q, conjunction with negation P, disjunction with Q. So consider P disjunction Q present in a column number 3 and negation of P disjunction with Q is present in a column number 5, and we have to take a conjunction operation, or we have to take a series connection. Conjunction means it is a series connection and disjunction is a parallel connection. So we have to take column series operation on column number 3 and column number 5. So we know the table of series, that means S1 and S2 are connected in a series way. Then there are only one possibility that values are 1 if S1 is 1 and S2 is F. That means P is T and Q is T, then it is T, otherwise it is a F. So observe column number 3 and column number 4 and take the operation as a series. So 1 1, that is 1 1 0 0 1 1 1 0 1 0. Observe this. It is the outcome. It is outcome of switches connecting in a series way. So P disjunction Q, that means S1 connected with S2 in a parallel way. Again it is connected in a series, that is negation of P disjunction with Q. So while we constructing a switching table of any logical statement, we have to consider the given statement as a switches S1, S2 and S3. So it is the basic idea to construct a truth table or switching table of any logical statement. With the help of this, we can construct any switching table of any logical statement. So it is the basic idea to construct a switching table, and it is the again basic idea we have learned to that means if we have given a logical statement, then we can find out the switching table. If we have given a logical statement, then we can construct a circuit diagram. There are two methods. So if we given logical statement, we can find out the circuit diagram. If we have given logical statement, then we can construct a switching table. So it is a two method. So it is a basic idea in a logical mathematical logic. So once again I want to recall you what we learned in this chapter. So we learn in this chapter there are 4 operations, that is conjunction, disjunction, implication and double implication are the 4 basic operations in this logical statement, or in this chapter we have learned. Again after this we have learned the tautology, contradiction, contingency and contradiction and contingency. There are 3 types which can be denoted by constructing a truth table of any logical statement, and we can conclude whether it is tautology, contradiction or contingency. Again next in this period we have construct a circuit diagram. If we have given logical statement, again we have construct a switching table if we have given a logical statement. So it is a basic idea how to study the mathematical logic. It is a very short note how to recall, how to remember this statement or how to remember this operation. It is a short tricks. Again in the last in a next period we are going to learn the next chapter, that is a matrix. So today it is enough. So I will continue tomorrow. Thank you.